Before to start, we must keep in mind that what we are going to see next are tips related to the creation of surveys and questionnaires, for which we will make use of R and RStudio in order to visualize survey information and to exemplify how survey and questionnaire data can be analyzed. To begin, we must understand that the data collected by surveys and questionnaires can be represented in several ways. So we will make use of three ways to visualize the information using R and RStudio, which are line graphs for Likert, scale data, pie chart, and bar plots. However, before starting to visualize information, there are two things we must do. The first is to install the packages that will help us throughout the practice, and the second is to activate the packages. To install the packages, we must execute this code block that will take approximately 5 minutes to complete its execution. And to activate the packages, we will execute this code and will take approximately 1 minute or less. Having done this, now we can start with line graphs for Likert data, for which we can use fictitious data. In this case, we will use data from students about the satisfaction in any courses, uh, language courses, and we call to this link and we save this data in this variable called LDAT, and here we are declaring two variables that we will use later. To check that the data have been loaded correctly in LDAT, we can execute the following code in which we define that we want only 10 first data, and we set a style for the table. And you can see the result of the settings here. LDAT contains information from two columns, which are the course, which can take the values of German, Chinese, and Japanese, and another column with the level of satisfaction, which only takes values from 1 to 5. With this information, we can make a cumulative linear graph, which we can obtain by executing the following code. Now, let's see how the information can be represented in pie charts, for which the first thing we can do is to modify the data in such a way that we obtain counts and percentage to make sure we can print a table with this information. And if we run this block code, we can see a graph that allow us to identify the level of satisfaction with a pie chart which has a color associated to each level. However, if we don't have percentages, it is difficult to interpret these graphs, for which we will execute the following block of code where we add the percentages. Deep side, this is difficult to read, so we have to position the values of the percentage according to the level of satisfaction. For this, we create the variable PDAT and copy the values of BDAT, which in turn contains the information of LDAT modified. However, to PDAT is added the position that should have each percentage to better visualize the pie chart. After that, we can execute the following command block to separate the information according to each course and not in a general way, and to graph it we use the following command block, this block of code, and this is the result for a general pie chart. And executing this code, we will obtain the pie chart by course and satisfaction. We can also represent frequency information with bar plots. For this case, we will use the same fictitious date that we use for the pie charts. To print the bar plot chart defining the characteristics with the following command block. Another way to see this data in a better way is if we divide the information by courses. The following code block helps us to do this by including the frequency, the percentage, to a new variable called GLDAT that copies the value of LDAT that contains the original dummy data. To see that the data has been copied correctly, we use the following code and we can see the data. Afterwards, we can print the data in a bar plot with the following code, in which we also define the properties of the bar plot. And here we have the course and satisfaction in a bar plot. Another useful way to view the data is to use Likert, for which we will use the Likert function and load the information in the variable SDAT with this line, and then observe that the information has been loaded correctly by displaying the table with the first 10 rows stored in SDAT. As you can see, the questions have dots instead of spaces, and they are missing the question mark, for which we execute the following code block that will also allow us to add an identifier to each question and eliminate the unnecessary blank spaces. After this, since we already have the questions well formulated in columns, we will assign a variable value to each numerical value with the following code block. To visualize the survey data, we can use the plot and Likert functions. With this line, we can view using the plot and Likert functions. To save the graph, we can execute the following code. Likert also allows us to group the data shown below by executing the following code block. And we can define the questions that we want. For example, if we want the question 1, from the question 1 to question number 2, maybe, we can change the parameters. And here we have the functions. These parameters goes from 3 to 11.
Hi, for this section, we will explore some useful statistical measures when dealing with survey data. Specifically, we will focus on two key sections: evaluating the reliability of questions using Cronbach's alpha and omega, and methods of merging variables as factor analysis. I'll guide you step by step through the R code and the interpretation of the results for each question. First of all, why use Cronbach's alpha? Cronbach's alpha measures internal consistency or reliability of a set of questions that aim to measure the same concept. High internal consistency means that the questions are well correlated and effectively measure the same underlying concept. So, to calculate Cronbach's alpha in R, first we will use these packages, and we need to make sure that they are activated. Then, make sure that the survey data is loaded correctly into a data frame to inspect the data. So for this example, the inspection of the data, the result is this table. The inspection of the data shows that the responses of the participants are the rows and the questions represent the columns. The columns name shows that we have 15 questions and that the first 5 questions test how outgoing respondents are. To check if the first 5 questions reliably test extraversion, we calculate Cronbach's alpha for these 5 questions. So here we have the function, and we need to specify the set of questions that we are going to evaluate. And here we have the results. The output of the alpha function is rather extensive, and we will only interpret the select output here. The value under alpha is Cronbach's alpha, and it should be about 0.7. The values to its left and right are the lower and upper bound of the confidence interval. The values in the column with the header G6 show how well each question represents the concept it aims to reflect. Low values indicate that the question does not reflect the underlying concept, while high values 0.7 and higher indicates that the question captured the concept well. In this case, 0.97 indicates a very high level of internal consistency among the questions. This means the questions are highly correlated with each other. The next measure is omega. And why we use omega? Omega is a reliability measure that estimates the general factor saturation of a test. It is considered a better estimate of reliability compared to Cronbach's alpha, especially for complex data. So to perform omega in R, we need to activate the packages, in this case UFS, and we will calculate omega for the same set of questions. The output is not as extensive as Cronbach's alpha, and we have key information here. For example, omega total, that indicates the overall reliability of the test. A value close to 1 suggests very high reliability, and in this case, we have 0.98. Then we have omega hierarchical, that represents the general factor saturation, and here we have 0.95. Then factor analysis, we are going to use it to identify underlying factors that explain the pattern of correlations within a set of observed variables. This is useful for reducing the number of variables and identifying common themes or constructs. To perform factor analysis in R, we are going to use psych and GPA rotation packages, and we will perform a factor analysis with 3 factors and variable max rotation. And here we have the results. We have many sections. The first one is uniqueness, that indicates the variance not explained by the factors. In this case, lower values are better. For example, question 1 outgoing has a uniqueness of 0.09. That means 91% of its variance is explained by the factors. In loadings section, we can notice how strongly each question loads onto each factor. In this case, higher values indicate stronger associations. For example, question 6, intelligence, loads highly on factor minor 0.82, suggesting it is primarily associated with this factor. In this case, factor 1 seems to relate mostly to intelligence items. Factor 2 relates to outdoor items, and factor 3 appears to be less clearly defined, but may capture some remaining variance in intelligence. In SS loadings are sum of square loadings for each factor, indicating the variance explained by each factor. For example, factor 1 explains 7.29, factor 2, 4.78, and factor 3, 1.02 units of variance. The portion of variance indicates proportion of variance indicates the proportion of total variance explained by each factor. In this case, 49%, 32%, and 7% of the variance. And finally, cumulative variance indicates the cumulative variance explained by the factors. In this case, the 3 factors together explain 87% of the total variance in the data. Finally, we have the chi-square test, that tests if the number of factors is sufficient. A p-value of 0.482, which is greater than 0.05, indicates that the model with three factors fits the data well. In other words, there is no significant difference between the model and the others, and the observed data, meaning three factors are sufficient. Finally, the results of a factor analysis can be visualized so that equations will reflect the same underlying factor are grouped together, as we can see here. This plot shows that the equation form clear groups, indicating the effectively measure the intent concepts. However, question 10 doesn't strongly correlate with the other intelligence related questions. In conclusion, it might be better to remove question 10 from the survey, and as it doesn't seem to measure intelligence accurately.
My name is Erick Lasluisa, and I'm going to expose to you the topics about principal component analysis and also the ordinary regression. So first of all, I'm going to start with the principal component analysis. This is also known as PCA, and it's used when multiple questions or variables reflect a common factor, and they should be combined into a single variable. So for this example, we are going to use the survey data dataset, which have, as we can see right here, have 15 questions about the outgoing. So for this exercise, we're only going to use the first 5 questions, and as we can see, with a correlation as true. So when we run this code, we can see with the summary, we get a print of all this data, and we can see here that, well, the importance of components as says here. And we can see that the component number 1 has, first of all, a proportion of the variance of 0.9159, which could be interpreted like as, we only lose 8.42% of the variance if we use this specific component as an indicator for outgoingness rather than the 5 individual items by itself. So next, we're going to execute this function, which is loadings, and with the principal components, which is a variable where is stored all these the PCA. I forgot to mention, but this print comp is the function to obtain this PCA. So when we run this code, we have here, well, these loadings, a function is used to check if these components represent one and no more than one underlying factors. So as we can see here, there is only one and only one. Next, we're going to make a plot to review all this information in a graphical way. So we're going to use the function plot with the principal component, and in type we put lines. So as we can see here, we have all these 5 components, and we can see that the component 1 is higher than the other ones. We can see that this component is much, much higher, and from the component 2 to the component 5, they are lower. This means that we can use this component 1 as our principal component, or as the indicator of the outgoingness. Okay, so okay. Now we're going to use this scores function that show us all the rows from this dataset. So we can see that the component 1 have all these data. That is the one that we're going to use. Okay, so yeah, this component 1 will be will replace all the other 5 items, and they will be grouped just in this component 1. Now we are going to review the ordinary regression. We have to mention that the ordinary regression is very similar to multiple linear regression. The difference is that this takes an ordinal dependent variable. Okay, so first of all, for this exercise, we're going to use a dataset that is stored in this link. So when we run this code, we can see here that there are 400 observations of 4 variables. We can see here our data, which is the variable where is stored all this. So we have these 4 variables that recommend internal, exchange, and final score. As we can see, we have internal and exchange with values of 0s and 1. This exercise, all these variables and these observations are for an example of 400 observation of students from a specific school. And this data represents internal if they are from the school or they are external. Exchange if these students are currently or have been in an exchange in the exterior. The final score represents the final score of a language test, and recommend is a recommendation for that specific student to be part of a committee of a program. So the first step that we're going to do is to factorize the variables that we have here for the data to be more understandable. So we're going to change 0 for external and 1 for internal, and in exchange, 0 for no exchange and 1 for exchange, as we can see right here. So we are going to run this code, and now our data will be refreshed. So now we can see that external, internal, and no exchange and exchange instead of zeros and ones. Now we're going to do an F table. And with this, we can see how these variables are related between them. So as an example, we can see that there are students that are currently in an exchange, and that recommendation is unlikely. For this, there are 25 observations of students that were external and 6 observations of students that were internal. And with the other examples as well. So we are now going to do a summary of this data set, but specifically with the final score. We do this because the final score is a quantitative variable, and it cannot be tabulated as we do here if we don't convert the factor as it says here. So we have that for the final score, we have a max score of 4 and a minimum score of 1.9. We also have a median of 2.99 and a mean of 3. Now we're going to combine all this data, including the final score and all these data from the exchange and recommendation, and if it's internal or external. So for that, we use this particular code, and we're going to visualize it as a plot. So now we have this plot right here. As we can see, it's divided in groups, as we can see in the table that it's up. So what we can see in this plot is that we have the final scores in each of these boxes that goes from 2 to 4, and it's divided by external, internal, and also all, as well as exchange, non-exchange, and all. We also have the recommendations that are unlikely, somewhat likely, and very likely. As we can see in this plot, there are few internal students that we have observations. Well, we're moving on, and we are going to do, okay. But this is the part that we are going to have the ordinary regression, and with this function that is POLR. So with this function that is stored in the n value, and then we do a summary of this model, we can see some interesting data showing that the students that have studied here at this school, which means that they are internal, have more chances of receiving a positive recommendation than the ones that the one has that are external of the school. Also, we see that have been on an exchange has a negative impact on the recommendations, but it's not a high a proportional effect to the recommendation. And we also see that the final score of the language test is also one of the main related variables that are considered to have a positive recommendation. And then we are going to group all this data in a table. So we're going to use the coef and the summary of the model with the function ctable. Stored in the variable name ctable. Now we have all the data that we have here, but in a table. As we can see, in this table, we only have the t-value, but we don't have the p-value. That is the value of the probability of receive a recommendation. So we're going to calculate that p-value. For that, we're going to use this piece of code that we can see that is using the p-norm function with the absolute value of the row of t-value of the c-table. Now that we have calculated all the p-values, we are going to combine the table, including this p-value. So we use this cbind and store it in the same C table that we have before. Now that we execute this piece of code, we have this. So now we can see that it is a similar table than the one showed before, but with the difference that we have the p-value here. Now, we can see that using this piece of code, we can have the confidence intervals and also have more statistics of the percentage of the how are these variables related to receive a recommendation. As we can see, the odds ratios show that there are 285% more likely of internal students to receive a positive recommendation than the ones that are external. We also see that the ones that don't have an exchange also have 106% more possibilities to receive these more likely recommendations. And we also see that the final score have 185% more to receive a good recommendation. We can see that the final score and the fact that the student is internal or external are more important than if they were on an exchange or not. So the final step to complete this exercise is to show all this data in a graphical way using a plot. So we are here modeling the plot using the predictions in a probability way and having all these tags. So now we do this data frame where we can see in a better way all these probabilities. For an example, I want to show you that the group of students that are more likely to receive an unlikely recommendation are the ones who are external students who have been on an exchange and those who have received a final score of 2.59. This group of students have 66.09% of probability to receive an unlikely recommendation. Now we can visualize all these predictions in a plot. So we have this here. This plot is basically representing this table, but in a graphical way. And that's the end of these exercises. As we can see, we have here the citations, and we also have this session info to end this practice. So here in the session info, we can see all the package that has been used in our project. And that's it. Thank you for watching.